Hello everyone, good evening. I hope all of you are doing well. Okay, so today we are discussing about the topic equilibrium constant. As you know, we covered the topic first of all the mole concept, stoichiometry, and equivalent weight. So based on the stoichiometric calculations, a similar topic we are discussing Kp and Kc, or you can say equilibrium constant, right? As we have done stoichiometry, so it is easy. It is nothing tough now. If you know how to use stoichiometry or reaction, how to use a balanced equation, so you can solve these questions very easily. Okay, so we are practicing these questions. Okay, let us see then. First of all, if we talk about the equilibrium, so what that means, if I talk about a little bit. So you see here, imagine we have a reaction. This is A here, this is B, and here we have, these are reactants and these are in equilibrium with the product C and D, right? If I write the balancing coefficient, if I balance the equation, it's small a, small b are balancing coefficient, right? And capital A, B, C, D are the reactants, or you can say products, okay? And small a, b, c, d are the balancing coefficients. Fine, bacha? So here, when I'm saying the reaction is at equilibrium, so the one and the main condition for equilibrium is the rate of forward reaction must be equal to the rate of backward reaction at the time of equilibrium, right? When this condition will be achieved, we can say reaction attained equilibrium. Maybe reaction started from the initial, maybe reactant were present and product were zero, right? But after some time, you see reaction starts, reaction going forward, reaction start also backward because it is reversible reaction, and after certain time you will see the rate of forward reaction will become equal to rate of backward reaction. So we can say reaction attained equilibrium. The observable properties like the concentration of A, B, C, D, or I can say reactant and product will become constant, or their partial pressure will become constant, right? Properties like concentration, partial pressure, density, you can say color, okay, those which we can observe will become constant, or I can say stop changing. Fine. It will look like that nothing is happening, reaction is stopped, but no, reaction, or I can say equilibrium, is dynamic in nature. It means reaction going on, it is not static. Reaction going in forward direction as well as backward direction even at the equilibrium, but yes, with the same rate. So it will look like nothing is happening, but remember always the rate of forward reaction and the rate of backward reaction, or you can say forward process, backward process, will become equal at equilibrium. Concentrations, if I say, the very common question comes always, sir, at the time of equilibrium, concentration of reactants and products will be same. No, there is no such condition. Concentration of reactants can be something else, concentration of products can be something else. Maybe in this reaction A is something, B is something, C something, D something, we don't care about it. We can't say it is a condition. The only condition is rate of forward equals to rate of backward. That is the condition, right? You can say here the rate of forward reaction will be equals to rate of backward reaction at the time of equilibrium. Clear, bache? Right? Now you know very well, if I'm giving you in short, if you write the rate of forward reaction by the law of mass action, I can say, what is rate of forward reaction, beta? I will say rate constant of forward reaction, and what here? The concentration of reactants, A power A, here I can say B power B, right? And similarly, what is the rate of backward reaction if I say? It's rate constant of backward, and here we have C power C and D power D. Clear? It is the rate of backward reaction, it is rate of forward reaction, and at time of equilibrium both are same. So if you see from here, if I will take this KB this side, so this KF by KB, okay, I can write it as this one. I can say C power C here and D power D. As I said, these A, B, C, D are representing the reactants and products, and the small A, B, C, D are their coefficients. Clear, bacha? Right? So from here, the ratio of the rate constant of forward direction and the ratio of the rate constant of backward direction, this ratio is known as equilibrium constant. Okay, this year in the NEET exam they asked question based on this only. So every year they are asking one question from this topic, very easy question. Okay, you see here this kf by kb, this ratio is known as what? Kc I am calling, right? Because I am writing here the equilibrium constant in terms of what? In terms of concentration. That's why I am saying, right? This is the expression. This is the expression for your equilibrium constant. Fine, bacha? Okay. What is this bracket A, B, C, D representing? These are representing concentration of A, B, C, D. This thing, beta, or this thing, or this thing, or this thing. What are these? Concentrations. These are concentration of A, B, C, and D at time of equilibrium. Okay, or I can say at equilibrium. These are the concentrations at time of equilibrium or at the equilibrium, right? You cannot take these are initial or final. These are at equilibrium. When equilibrium is established, then what are the concentration of A, B, C, D? Fine, bache? Similarly, if you are finding the equilibrium constant in terms of pressure, we call it Kp. So I will say here, same reaction I am taking. You can say pressure of C, power C here, partial pressure of D here, power D, partial pressure of A, power A here, and partial pressure of B, power B. This thing is also equilibrium constant in terms of partial pressure. If you take here partial pressure, then it is Kp. If you take concentration, you can take which one? If you take concentration, it is what? Kc. Here I am taking the concentration of ABCD at time of equilibrium, and what is these? If I talk about, so what is this PA, or what is this PB, or PC, or PD? So these are the partial pressures. These are the partial pressures at equilibrium. These are the partial pressures at equilibrium, right? Clear? The Kp and Kc, we can find the equilibrium constant in two ways, and we can relate them also, right? So how we can relate? If you see, we know very well that Kp will be equals to Kc. So you can say RT power delta Ng. You can relate these. What is that? Kp equals to Kc, RT to the power delta Ng, right? So small topic we are discussing today, that is equilibrium constant. I'm not going in detail with the you can say characteristics or everything. We are approaching the questions basically. So I'm saying once again here, one is Kc thing, one is Kp things, and one is what beta? Kp Kc relationship. On this basis question came this year in the NEET exam, right? Let us see small questions on base of Kp and Kc, right bacha? Okay. So you see, I'm taking the smallest easy questions from the start, then we'll move to the type of different questions. Imagine I'm taking a small question here. This is 2 of A, 2 of A, B, and here this 3C. Again ABC are the, you can say ABC are the what you can say beta, these are the reactant products, and directly I am giving when equilibrium is attained. So at the time of equilibrium, you can say at the time of equilibrium, I am saying A is 5 molar, B is 3 molar, and C I am saying, imagine C is 4 molar. Whatever concentration is given to you at the time of equilibrium, you have to use it as it is. I am saying once again, whatever concentration is given to you, you can use it as it is, whatever is given. It can be anything, whatever they give, right? So you have to find Kc. Now I know what is the expression of Kc beta. It's a, you can say C concentration here and cube, right? and here we have A, its square, and here we have B power 1. Fine. So you can see the value beta. It's 4 here, it's 4 cube here, and A how much? A is 5, and you can take its power 2, and here it is how much? 3, and power how much? 1. Clear? What it is that I'm saying once again? C here is how much? 4 molar. At the time of equilibrium, C is 4 molar, right? So 4 molar power cube, because its coefficient is 3. A, you can say that A is 5 molar here, power 2, as coefficient is 2, and B is 3 molar, power how much? 1. Okay? Can you solve this data? Yes, bacha. Can you solve this thing? What's coming from here? 4 cube how much? 4 16 into 4, how much coming? 64, right? It's coming 64. Whereas it is coming how much? 25 into 3. Clear, bache? So what's coming Kc from here? Yes, but what's coming Kc from here? Tell me. So 64, you can say here 64 divided by 75. 64 divided by 75. Fine, bacha. The easiest question of this type. What was it? In this, they gave the reactant concentration and the product concentration directly at time of equilibrium. So nothing tough in this case. You have to just put it as it is in the given data. Fine, beta. Yes, Gayatri. 64 by 75. Good, bache. Good. Now, we are changing it step by step, right? So it was the simplest question I can say, right? The next question I'm taking here. Okay, if I'm saying here, you can see beta. Again, imagine we have 2 of ammonia here, 2 of ammonia, here we have N2, and here we have S2, right? 2 of ammonia, N2 and S2. I'm saying in this case, at time of equilibrium, I'm giving easy question again, just give me data. Imagine it is 5 molar, it is 2 molar, it is 2 molar, right? At time of equilibrium, all the concentrations are given, okay? So again, our task is very simple. You have to find Kc. Then I will change the type. Yes, Gayatri bache, tell me the answer fast. Everything is given in the question. They gave the concentrations at time of equilibrium. Easiest question. Okay? And you should know, if by chance there is any solid is there or there is pure liquid, so their concentration will be taken as what? 1. Okay? We will not write those things which are you can say solid or pure liquid in our equilibrium constant expression, or I can say we will take it as 1. Their concentration will take as 1, right, bacha? You can see here. So easy again. Kc, I will say ammonia beta. Okay, ammonia is this time what? Ammonia is your reactant, right? So N2 beta, N2 how much? 2 power 1 I will take, and S2 also 2 power 3 you can take, and divided by how much coming here? Ammonia is how much? 5. So power square. So 2 power 4 is coming, right? Yes, 2 power 4 is coming. You can say 16 by 25. Fine. 16 coming? Yes, 16 by 25. Good. Okay. Okay, Jashu, 16 by 25. Fine, bacha. Now the next thing is little change we are doing in the question. Imagine we have 2 of ammonia here, and it is giving us N2 and what? S2, right? At time 0, be careful, this time I am changing a little bit. I am saying at time 0 means initial time. I am not writing the question in form of like a statement or lengthy question. I am just directly saying at time 0 means initial time when I am starting the reaction. When I am starting the process, I am saying here, imagine it was 10 molar. These are 0, 0 at initial time, right? And in this case, I am saying at time of equilibrium, I am saying it is better. If I am saying at time of equilibrium, you can say it is 4 molar. At time of equilibrium, it is 4 molar. So your task is to again find the Kc. In this question, they have not given us these concentrations at time of equilibrium. So using the stoichiometry, simple stoichiometry, we have to find their concentration first of all, and then we have to find the Kc. Tell me, bacha. Yes, sir, Jashu. Tell me, what's coming? Easy question, stoichiometry based topic, nothing new. What's coming here? You see, the ammonia decreased beta how much? 10 to 4, right? 10 to 4 decreased. How much finished? 6 finished, right? 6 finished. So we have to observe how much ammonia consumed. We know very well that when 2 ammonia consume, how much N2 form? 1 form, right? When 6 ammonia will consume, 2 consume, form 1. So 6 consume, form how much beta? It will form 3 molar. It will form 3 molar, right? Unitary method I am applying again. 2 of this makes how much? 3. Its 2 makes 3. Its 2 makes 3 here, right? So 6 beta will make how much? You see, you can apply unitary method. 2, like I'm showing you just simply, 2 of ammonia makes 3 of H2. So 1 will make how much? 3 by 2. And 6 will make how much? Unitary method I am applying just simply 3 by 2 into how much? 6. So what's coming? 9, right? You can see easily 9. It's 9 molar. So when it will decrease from 10 to 4, means 6 gone. So how much will form here? 3 will form, 9 will form. So at time of equilibrium, I have the concentration of everything which I need to find my Kc, right? What I will do here? So what's coming at Kc? Kc coming 3 power 1 is coming 9 power 3 and divided by how much beta? 4 power 2, right? Okay. What's coming? 2187, right? Okay, great. So from here if you solve beta, I think Gayatri is saying yes, 2187. So I'm taking it as it is. Divided by how much? 16 here, right? Okay, fine. You can easily see what is 9 cube coming from here, and 9 cube into what? 3. Okay, bacha, I hope we are clear about this. So our main task is to find the concentration of reactants as well as product at time of equilibrium, right? So here I found, here what was new? 10 to 4. So how much consumed? 6 consumed. Using 6, I can find easily how much of N2 and H2 will be formed, right? And then I have the concentration of all of these at time of equilibrium. So very easy to find Kc. Fine, bacha? Right? Next time taking. Okay, same. On same basis only. On same basis, I am saying like 2 of SO3 here is giving us 2 of SO2 plus O2, right? So at time of 0, imagine they are giving us it is 5 molar. It is 0, 0. And at time of equilibrium, beta, imagine they are giving O2 is 2 molar. We don't know their concentrations, right? And again, question is very simple. Find Kc. Find Kc, right? Think about it. Everything is gas. If something will be solid, I will tell you. Everything is gas here, right? All are gases. Can you find Kc for this? Think how much product is formed. How much product is increased? Product will increase. Here product is increased how much beta? 0 to 2. It is 2 formed, right? It's 2 formation. You see beta, it's 1 will form when it's 2 will form. Both are product, na? It's 2 is formed. So it's how much will form? 4, right? So 0 to 4. How much? 4 molar. Clear? And in this case, you see, it's 1 will form when it's 2 will consume. It's 2 will form when how much will consume from here beta? 4 will consume, right? So how much remaining here? 1 molar. Clear? So from here you see what is coming Kc beta? Kc is coming SO2 product and coefficient as power, and O2 here power 1 divided by what's coming here? Divided by, you can say, SO3 and square, you can say, right? So what's coming? 4 square, 2 power 1, and yes, 1 power 2. Yes, beta, 16 into 2, 32. Very good, Gayatri. Right answer. How much coming? 32. Fine, bacha. I hope we are clear about this. Okay. The easiest questions here. If they gave initial, they gave final, so I can see how much one thing is increasing or decreasing. And using that, I can find the remaining things. Very easy. Here I am not using any alpha, just simple concept. Clear, bache? Okay. Now, look at this. If I'm having a very simple question. Look, carefully you have to see. Don't make mistake. Look. Again, I'm taking a simple reaction. 2 ammonia is giving here N2 and S2. Okay, I'm taking a little more simple for the first case. Very simple I'm taking. It's PCl5. PCl5 gas is giving us PCl3 plus Cl2. All are gases. Okay. If I'm not writing anything, you will take gases all the time. So, at time of 0, beta, at time of 0, initial time, right? I am saying it is 5 molar. It is 4 molar, and imagine it is how much, beta? I can say something, imagine 6 molar. In the initial point, when I'm starting the reaction, it is 5, it is 4 and 6. I can take product also in the reaction, no issue. Okay. So, and at the time of equilibrium, we observed that it is 7 molar. So you have to find their concentration and then find Kc. Okay, it is good question where students make mistake all the time. It's a good question where students make mistake all the time. So carefully give the answer. Yes, bache. It is 5 molar, it is how much? It is 7 molar. So how much increased? You see, the reactant amount is increasing. So net reaction is going forward or backward. You see, first of all, I will not say reactant product. I will say the left side thing and what? Right side thing. It is more easy. Okay. You see, its amount is increasing. It was 5, now become how much? It was 5, now become 7. So 2 increased. So net reaction, my question is, net reaction, when after we started the reaction going forward side or backward side? Reaction is going forward side or backward, right, beta? Tell me. You see carefully, the reaction, it was 5, now becomes 7. So how much increased? 2 increased. It 2 increased. So actually net reaction coming where? Net reaction coming back side. Clear, bacha? You see, its 1 will increase when its 1 will decrease. Its 2 increased means its 2 will decrease, beta. Its 2 will decrease. So how much will remain? 2 molar. Right? Its 1 will increase when its 1 will decrease, right? So its 2 increase, so its 2 will decrease, na? So how much is gone from here? 2 gone. How much remaining? 4. So from starting to the equilibrium, reaction is going where? Reaction is going backside or backward. Okay, I'm saying once again, from when we started time 0 to time equilibrium, net reaction going backside to attain equilibrium, right? Now I will write the Kc expression. The Kc expression is PCl3 divided by Cl2 divided by what? PCl5, right? Now some students make mistake here. That first of all, the students make mistake here. They do mistake in this part. Second mistake they do, sir, reaction going backside. So I will write Kc expression reverse way. No. Kc expression depend how you are writing the equation. Kc expression always depends how you are writing the equation. So Kc expression always right side thing comes upside and left side thing comes downside. Even reaction going backside, I don't care. The Kc expression will come PCl3 into Cl2 divided by what? PCl5. Okay? This will not depend reaction going forward or backward. This depends how the reaction is written. I don't know what is happening here, but Kc expression is fixed. Right side thing upside and left side thing where? Downside. Clear, bacha? What is the point? Yes, okay. Now you can tell me the answer. Tell me what is the answer coming. Yes, Gayatri. What's coming, beta? What is the answer coming? Tell me fast. What is coming? If you put in the given equation, beta, what is coming? It is how much? 2. This is 2 power 1. This is 4 power 1. And divided by how much? PCL 5. PCL 5 how much? 7 power 1, right? So it's coming 8 by 7. Easy? It's coming 8 by 7. So very easy. Clear, bache? Done? Okay. The next thing. The next I'm taking. Next question. On the same basis. Don't make mistake. On the same basis I'm giving here. So if I give, take this one. It's N2 here. It's S2 here. 2 ammonia. Okay, this is the reaction. Yes, we got the right answer. Now give me answer for this question. At time 0, I'm saying it is, you can say, it is 2 molar. It is 2 molar. Imagine it is 10 molar. And at time of equilibrium, I observed that it become 4 molar. It become 4 molar. So find their concentration. And again, the question is very simple. Find Kc. First of all, at time of equilibrium, they gave me N2 value. Initial was 2, now 4. So first, predict the direction of reaction. Net direction of reaction. Where reaction is coming? Reaction is coming backside or reaction going forward side to attain equilibrium. Right, bacha? And then find the H2 amount, then find the ammonia, and then find the Kc. Tell me fast. Is bache? You see here, how much is increased? 2 increased, right? And 2, you see, beta, it was 2, now it is 4, na? So 2 increased. So means reaction going where? Reaction going backside. If reactant side is increasing, or I can say left hand side is increasing, reaction going where? Backside. Right? Same question I'm giving this basis, right? How much increase? 2 increase, right? I can say its 1 will increase. So its how much increase? 3. Its 1 increase will increase its 3. Its 2 increase will increase how much? It's a 6 will increase, right? 6 increase. Total how much? It become 8 mole. Its 1 increase, 3 increase. 2 increase means how much increase? 6 increase. Initial was 2, 6 increase, 8 will be final, right? And in this case, good bacha, its 1 increase consume how much? 2. 2 increase will consume how much, beta? 2 increase will consume how much? 4. So out of this 4 gone, so 6 will remain, okay? So in this way, if I want to find the Kc, again as I said, the equilibrium expression will be written on basis of how reaction is written, okay? Reaction going forward, backward, it will not affect the expression, right? Ammonia is 6 power square here, right? And you are saying here 4 power 1. And here beta 8 power cube, right? Good. 6 you can say how much? 36. Yes. 36 cut down by 4, right? Yes, it is coming 9, right? And 8 cube, yes, you can say 5 and 2. Yes, beta Gayatri, right answer. Good. Great. It's coming 9 by 5 by 2. Fine. Right, bache? This is 1 or 2 type of question we have seen, right? We are moving step by step. Now next type you will see. In the Kc expression, we are putting the concentration of reactants and product. Concentration means what? Concentration means the number of moles divided by volume. Sometimes we do mistake, we just put the moles. No, concentration we have to keep in the Kc expression, not the moles of the ABCD. Okay, bacha? And what is the concentration? Mole per liter. Mole divided by the volume. Okay. So this is the question here. Simple one. Imagine here we have 2a plus b here, giving you 3c, right? It is simple equation. At the time of equilibrium, imagine directly given to you, it is, I am saying A have 5 moles, right? B here I am saying, you can say B here 10 moles. At equilibrium B have 10 moles, and C here I am saying, imagine 15 moles, whatever they give, right? Yes, bacha, right? Yes, beta, marks are little less, but yes, you can wait a little bit. Okay, it can go that much down. Let us see. Paper was little tough, so cut off will be little down, but it will be that much. We have to check. But yes, you can have chances. You have chance a little bit. Okay, you can wait for it, or you start preparing, and then if you get the seat, you can enjoy your seat, right? But you have chances, I think. Okay, so what do we have here? 5, 10, and how much? 15. Clear? So what do we have? And I'm saying in the question, but I'm saying the question is volume of the container. I'm writing here clearly. The volume of the container, beta, is, I'm saying 5 liter. This reaction is going on in the vessel or the gases, and the volume of the container, how much? Sorry, 5 liter. Can you find the Kc, beta? By the given data, I'm asking what is the Kc. By the given data, tell me the Kc. Remember, you don't just keep the moles of the reactant product. You have to keep the concentration, that is mole per liter. Okay, give me the answer, beta. Give me the answer fast. Yes, bacha, tell me what's coming. This is the moles. Be careful. Mole given, right? So here you will see, if I divide by 5, right? So I can say it is how much? 1 molar. 10 mole divided by how much? 5. So how much? 2 molar. And here 15 by 5. So you can say 3 molar, right? So here I can say 1 molar. It's 2 molar. It's 3 molar. So my main concern, what I am telling mainly, if they gave, by chance if they gave you the moles, don't forget to make it concentration by dividing the volume, right? Now the very easy beta, see how much? C is 3, power 3 here, it's coming how much? 1 power 2, it's coming 2 power 1. So from here, yes, 9 by 2 is coming, right? 4.5. Clear? Done? Okay, great. Sorry, it's coming 3 cube, na? 3 cube they have given. 3 cube means how much? 3 into 3 into 3, 27, and divided by how much here? 2. Right? So what's coming from here? It's coming 13.5. Great, that's it. Yes, we're right. Great. Now the next thing is this one. Look at this. Same type of question I'm giving. It's H2 here. It's I2. And here they give 2HI, imagine. And I'm saying all are gases. All are gases, so nothing is solid here. And at the time of equilibrium, I'm saying, right? I'm saying I am having its 8 moles. I'm having its 8 moles. And it's, I'm saying, imagine we have its 4 moles. And it's, I'm saying, imagine we have 5 moles. And the question is very simple. Find the Kc. Find the Kc. Find the Kc. Okay, now one question comes to our mind. Okay, first think about it. In this question, do we need volume? In the Kc expression, this is very sure that I have to put the concentration of Hi, H2 and I2. But here they have not given volume. Okay, but without volume, can we find the answer? Without volume, beta, can we find the answer? Without volume, can you get the answer in this question? You see carefully, here you have 2 moles and here how many moles? 2 moles, right? So if you go, look at this. if you go for the Kc, moles, look at this, Hi, I'm saying Hi concentration power 2 divided by here H2 power 1, and here we have I2 and power how much? 1. Clear? So if you see beta, I don't need just moles, I need volume na, I need volume. So here moles 5, so imagine volume is V. So I will say 5 mole by volume V. It is the concentration, here power 2, and here I am taking H2, right? What is H2 beta? H2 is 8. Volume was V, so 8 by V I am saying 8 by V power 1, and I2 would have given 4. So 4 by V power 1. Clear? In this question? If you see here, what happened? If we solve the above part, the 25 is coming and divided by 8 into 4, how much coming? 32. And you see here V square and here V into V coming. If you solve this thing, V square coming downside, upside coming over V into V. So this V will cancel, na? If moles here and moles here are same, so V will cancel out. So without V you can find the answer. But like in the above question, number of moles were not same, right? In this question also it was possible, because by chance moles were same. How many moles here? 2 and 3, here also 3, right? But by chance if moles of both sides are not same in the equilibrium expression, then you need volume properly. Okay, by chance here in this case moles are same, here 2, here coming V square and here coming what? V into V. So it will cancel out. It will cancel out. But we need volume, that I am telling. If moles are same, then without volume we can get the answer. It's okay, because it will cancel out. But we need volume, not only just moles, right, Richa? What's coming? 25 by 32. Good. Okay. One last question I am giving on this basis. Try a small question, beta. It's 2 of SO3. Is giving here 2 of SO2 plus O2, right? So at time 0 beta, imagine at time 0 I'm saying it's 10 moles are taken. It's 10 moles, I'm saying 10 moles, right? And here 0, 0. At time of equilibrium, to make it very easy, I'm saying imagine just here now how many moles remaining? 4 moles remaining. Find their moles. Question is very simple. Find Kc beta. Find Kc if volume, I'm saying, if volume of container is 2 liter. If volume of container is 2 liter, right, Richa? Yes, Gayatri beta, tell me the answer. What's coming? First find the equilibrium moles. Using the volume, find the concentration, and then find the Kc. Very easy. In this case, I need volume because moles are not same. Here 2 moles, here how many moles? 3 moles. So volume is given to you, 2 liter, right? Otherwise you can't find the answer. Tell me. Fast. Tell me, bache, what's coming? If you see, bache, it was 10 here, right? 10 to 4. Decrease from 10 to 4. How much finished? 6 finished, right? 6 moles finished. It's 2 moles. It's 2 mole consumption produces 2 moles. So 6 mole consumption produces how many moles? 6 mole, right? So 8 6 mole will form here. It's 2 mole produce 1 mole. So 6 mole produce how many mole? 3 mole, right? Now we have mole of everything at the time of equilibrium. Okay? To understand what you are saying? Let us check beta. So these are the moles. Now we have moles of everything at equilibrium. I can find the concentration. How beta? SO3 how much if you see? It's coming 4 by 2, right? I'm having less space here, so I'm writing 4 by 2 coming. Here how much coming beta? 6 by 2 coming. And here how much coming? 3 by 2. So we have the concentration of all the things at time of equilibrium, right? Now in the Kc expression we can put very easily. Okay. I'm writing here. Okay. So look, what do we have here? Kc I can find. Kc coming. SO2 beta 3 coming, right? 3 power 2. How much O2 given beta? O2 given 3 by 2. So I'm writing it 3 by 2 only. It's 3 by 2. Power 1 only. And here how much? 4 by 2 means 2 beta. 2 power 2. So if you solve this thing, what's coming? 3 cube coming. 3 cube will come how? 27. And by chance here also 2 cubes. So how much? 8. 27 by 8. 27 by 8. Yes, beta Gayatri. Right answer. Okay, 27 by 8. Right answer. Okay, done. Clear? This way we can find. Okay. Let us see now. We'll look for the alpha. Now, how to use alpha, the degree of dissociation in our questions. Fine? Okay. So, let us understand first of all, what is alpha beta? A small point here which is very common in the questions, degree of dissociation. In the last year NEET exam, they asked a question of KP, KC on the basis of degree of dissociation, right? Degree of dissociation I will write by alpha, right? What is alpha beta? If you see, what is alpha? Alpha is number of moles dissociated. Alpha is number of moles dissociated divided by number of moles taken. Right? You can say here alpha is what? N, D divided by N. How many moles you have taken of that substance and how many of the moles are dissociated is alpha. Okay, so I'm writing here alpha is N, D divided by N, right? You can do one thing, first to this thing beta. Other thing is you can do one more thing here, alpha. If I divide it by volume V, ND by V, and here N by V. And ND by V is the concentration dissociated in terms of concentration, and it is the taken concentration. So I can say one more formula. Alpha is what? Alpha is concentration dissociated means finished and divided by concentration taken. In the both the ways you can use it. Number of moles dissociated divided by moles taken, and you can say alpha is concentration dissociated divided by concentration taken. In both the ways you can take. Clear, bacha? So what we have the next part, you see, what will happen in our questions, you will see, they will say, if I ask you initial concentration, okay, so initial concentration here I am writing as C. If I am saying out of this initial concentration, concentration dissociated, or you can say finished, it is what? CD. It is CD, right? Or I can say, what is CD? What is CD? C alpha. So C alpha is the finished concentration. So if I say concentration remaining, or I can say remaining concentration. So what is that? C was taken. Out of C beta, CD is finished. Or I can say out of C taken, C alpha finished, right? So be careful. It was the taken concentration. It is the finished. How much finished? And remaining how much? C minus C alpha. C minus C alpha, right? So I will use this in our questions. Next question, right? If alpha comes in our question, how to use the concept? We will discuss about it, right? I'm saying once again, C is the initial concentration of taken. Out of C, how much finished? C alpha. And C minus C alpha is what? Remaining. How much is remaining? Okay. Let us see one or two questions on this basis. Okay. Again, I'm saying here, first a simple question A. A is giving us 2B plus 3C. A is giving you 2B plus 3C, right? And imagine at time 0, I took here 5 molar concentration. These are 0, 0. Now A is finishing, or I'm saying here A is dissociating. Okay, and in the question, what is given, beta? It is given that degree of dissociation of A. I'm saying here degree of dissociation of A is 0.4. Alpha is given 0.4. So question is very simple again. Find Kc. Question is find Kc. This is the question. Find Kc. Okay. So initial how much? Initial beta how much? 5 taken. Initial how much taken? 5. Or imagine, I'm just showing you one more example here without data. Okay, same I'm showing. Look at this carefully. It was A. Here I'm taking here 2B and here 3C, right? Then you will solve by yourself. At time 0, taken how much? C taken. C is the initial concentration. If alpha is the degree of dissociation, then how much will finish, beta? C was the initial taken. How much finish? C alpha. This is it, how to use it. C was taken, C alpha finished. So how much remaining? Remaining is C minus C alpha. Initial, dissociated, remaining C minus C alpha, right? Now we can see 1 of A finishing, or when 1 A will consume, how much will form? 2. So C alpha will make with how much here? 2 C alpha. When it's 1 will finish, it's 3 will form, na? So C alpha make how much? 3 C alpha. So C alpha or alpha will help you to find how much will be consumed. And now how much is consumed, using that you can find how much of product will form. This way you will get the concentration of reactant and product at the time of equilibrium, and then you can find Kc. Yes, bacha Gayatri, give me the answer this way. Solve this question exactly same way. Give me answer. C is given, C alpha you can find because alpha is given, C is given. So how much remaining and how much product is formed, and then the main question you have to find the Kc. Okay, fast. चलिए बच्चा, what's coming? Okay, you see बच्चे, 5 is taken, right? 5 is the initial one. Out of 5, how much gone? 5 alpha. 5 into alpha. What is alpha? Alpha they give 0.4, right? So 5 into 0.4, how much coming? 2 coming, right? 5 into 0.4, 2. So at time of equilibrium, how much will remain? Out of 5, C alpha gone, means 2 gone. How much remaining? 3 molar remaining. Right? Now, we can see 1 of A give 2 of B. So 2 will give how much here? 4. 1 give 3. So 2 give it a how much? 6. Right? That's it. This is it. This is how we have to use the alpha. Now in the Kc expression, we can put it easily, the data. B beta, B how much? 4 square. C how much? 6 power cube divided by how much beta? 3 power how much? 1. Clear? So what's saying finally? 16, and you can see it as 6, how much coming here? Total coming how much? 152. Okay, I can say here 36 into 6, and here we have 3. 3 cancel out how much? 2. Okay, you are saying, guys is saying 1152. Fine, bache. Check calculations. You can check calculations once. Okay, I think it is right only. What's the point? How to use alpha? Exactly same way you have to move always. C alpha gone, C minus C alpha. So C alpha gone. Now you have to use the stoichiometry. How much product will form? How much product will form? Then you have to think about it. Clear, bacha? Okay, I'm giving one more question on this basis. So carefully give the answer. Finish up to here? Done? Okay. Now the next thing is, again very simple thing. I'm taking the simple reactions. Okay. So again very simple. At time 0, I'm saying you have taken the initial concentration 10 molar. I'm giving you very simple data so that you can solve it very easily. The concept is very much important here, okay? In the module practice, you can do the calculation little bit lengthy also, but here concept is more important. If you are clear about the concept, then you can solve easily any question, right? So here I'm saying with alpha, the degree of dissociation of SO3. The degree of dissociation of SO3, let me give you. Okay, I'm taking 0.4 only. Or you can take this time, I'm saying 0.8. Alpha is 0.8, imagine. Okay, so question is very simple again, find the Kc. Alpha is 0.8, be careful, alpha is 0.8. Whatever they give, we don't care about that part. Apply the same concept. Always you take C, C alpha gone. How much of product will form using that? Yes, bache. Move same way, exactly same way. You have to find things, you have to find the concentrations at time of equilibrium to find the Kc value. Tell me fast. Tell me, bache. Okay. So in this case, if you see, C is taken, right? C is taken. C is taken, right? C alpha will finish. C alpha will finish. 10 into 0.8. So 8 will finish. So how much remaining? C minus C alpha. After 10, 8 is gone. How much remaining? 2 remaining. Okay, good. Now the next thing is, it's 2 consumption make its 2. So 8 consumption will make how much? 8, right? Okay. 2 make how much? 1. 2 makes 1. So beta 8 makes how much? 8 makes 4. Then apply stoichiometry. That is same always. C alpha gone, C minus C alpha remaining. Using the like how much reactant consumed, using that apply stoichiometry to get the product, right? So what is this? What is Kc beta here? Kc is now 8 power 2, 4 power 1 divided by how much? Divided by 2 power how much? 2, right? So what's coming beta? Calculation if you do. Yes, 2 power 2 give 4, so 4 cancel out. How much coming? 8 power 2, 64. Correct, bachche? 64 coming? Yes, Gayatri, what's coming? 64. So I hope we are clear about this question. Same thing, they can give us mole also. They can give us moles. You use the alpha, you find the moles at equilibrium, and using the volume, you can find the, again, concentration to find the Kc. Okay, bacha? Fine. Okay, great. Okay, great. Now, the next thing is, imagine what we have here. Here we have, this is CaCO3. CaCO3 give you CaO and CO2 at time of equilibrium, but be careful about it, beta. This thing is solid. This is solid, this is solid, and this is gas. Okay, so solid things we don't take in the Kc Kp expression, or you can say we take their active mass or their concentration. How much? 1 we take. Okay, so if I write its Kp or Kc, but if I write the Kc expression, so in the Kc expression only what will come? Only concentration of CO2 will come. Okay, you can take it as 1 divided by 1, or I will say don't even write in the expression, right? Just CO2 is coming because this is gas. These are solids. Be careful about it. Clear, bacha? Okay, are we clear about this? Okay, so imagine if I give a simple question on this basis, same thing. CaCO3 is writing here CaOCO2, and we know it is solid, it is what? Gas. Now, what is written? Imagine at time of equilibrium, first of all, they will not give the moles of CaCO3 or CaO, but imagine in a vessel reaction going on, and they're writing, imagine they're writing in the vessel 4 mole of CaCO3 are present, and imagine its 5 moles are present, and I'm saying it's also 5 moles present, right? And I'm saying volume of the vessel is 2 liter, right? So my question is very simple, find the Kc. At equilibrium, this is the given moles. Most of the time they will not even give the mole of CaCO3 or CaO, but still by chance if they write the mole, this is the mole in the vessel present. These are the moles present in the vessel, imagine. If they ask you Kc, what you will do? I'm telling you very clearly, by chance if they gave you, first of all they will not give. Even if they gave, don't worry, Gayatri. Now you are okay? Gayatri, are we clear about this concept now? Or I should say it again? Are you clear now, bache, about this question? Are you clear now, or I should say it once again? Okay, I'm saying once. You see, beta, 10 molar was taken, right? It was 10 molar. Remaining out of 10, C alpha gone. C alpha gone means how much gone, beta? C alpha means 8 is gone. Out of 10, 8 gone. How much remaining? 2. It's 2 make it's 2. It's 2 makes 2, na? So 8 will make how much? 8. Okay. Yes, beta, yes. Listen carefully. It's 2 consumption make it 2. You see, out of 10, 2 remaining. How much finished? Out of C alpha finished. How much remaining? C minus C alpha, right? So C alpha finished, na? 8 finished. How much finished? 8. 10 into 0.8 is 8. Right? Yes, beta. You see, 2 makes its 2. When its 2 will consume, its 2 will form. When its 8 will consume, how much will form? 8. Right? Its 2 consumption make it 2. So its 8 consumption makes how much? 8. Its 2 consumption makes how much? 1. Its 2 consumption makes how much? 1. So its 8 consumption makes how much? 4. Unitary method. Got the point? I'm saying once again, when 2 SO3 will finish, 2 SO2 will form. When 8 SO3 will finish, 8 SO2 will form. Okay? Got the point? Okay? This will remain same. Okay, bacha? This will remain same. C alpha, C minus C alpha. Now you know how much C alpha finished. Now use stoichiometry. Right? 2 makes 2, so C alpha makes C alpha, right? 2 makes 1, so C alpha make what? C alpha by 2. I will give you one more question on this basis, right? I will say the next question, don't worry about it. So here I am saying, beta, Kc is the case. So I will say only CO2 will come in the expression. Okay? For solid will not come in the your Kc expression, or we will take its active mass as 1, right? So CO2. So I will say just 5 by how much, beta? 5 by 2. That is 2.5. Okay? That's it. Okay, bacha. So look at this carefully. I am explaining it once because many students do mistake here. I got the point why you are making mistake here, right? Imagine here coefficient is 3a and 3a is giving me 2b plus c. By chance this is coming. By chance this is given to you. Okay? Right, bacha? Now at time 0, I will go same way. I have taken C concentration initial, and They gave me alpha, degree of dissociation. They gave me in the question that alpha, the degree of dissociation of A is alpha, right? So out of C beta, out of C how much will go? C alpha will go, how much will remain? C minus C alpha will remain. So this part will remain fixed. C alpha is gone, how much remaining? C minus C alpha. This is remain same. Now come to stoichiometry. Now we know very well that its 3 makes its 2. Right? Its 3 make its 2. Its 3 is consuming its 2. Its 3 is consuming its 2. Right? So its 1 beta, its 1 will make how much? 2 by 3. 3 makes 2. So 1 will make how much? 2 by 3. So C alpha make how much? 2 by 3 into C alpha. 2 by 3 into C alpha. Right? Similarly, 3 makes 1. 3 makes 1. So 1 make how much? 1 by 3. So C alpha make how much? 1 by 3 into C alpha. So this is stoichiometry. This is simple stoichiometry. I hope we are clear now. Right? Okay, got the point? Okay, Vachi, let us see some KP questions. Then we will see some mixed questions, okay? KP is very simple thing. In KC, we are putting the concentration at time of equilibrium. In KP, we'll put the partial pressure at time of equilibrium. That's it, nothing different, okay? Now you see, again a very basic question I'm taking. Imagine 3A, it's 3 of A, 2 of B, giving 4 of C. And at time of equilibrium, it's very clearly given that its pressure is 2 atm, its pressure is 3 atm, and I'm saying its pressure is you can say 4 atm. Whatever they give, okay? So using this beta, find the Kp. I'm saying once again, Kp is, you take the partial pressure of product here, coefficient as their powers, partial pressure of A cube, right? Okay, tell me the answer, beta. What's coming from here? Exactly same way you have to go. Nothing is different in the questions of Kp. Exactly same, nothing different. What's coming? What do we have here? PB. Partial pressure beta, partial pressure of B how much? They gave 3. 3 power 2. Partial pressure C how much they gave? 4. 4 power 4. Divided by partial pressure of A how much they gave? 2. 2 power 3, right? If you see carefully, it's 2 atm given, it's 3 given, it's 4 given, right? So here 3 power 2, here 4 power 4, and here 2 power 3. Fine? Is it how much coming? 288 coming? Okay. Calculations you can check. 3 power 3 we know. How much beta? 3 power 3. 3 power 3 how much? 9. 4 power beta 4 how much? 64. And here how much? 2 power cube. 8, right? Are 288 coming, right? Check beta, check carefully. Sorry, it's 4 power 4 na, not 4 power 3. It's 4 power 4. This one, right? What's coming from here? 4, 2. 2 giving how much? 32, right? 288. Fine, good. Okay. Same, exactly same way. The question of pressure beta will come. PCl5, PCl3, Cl2. at time 0, imagine its pressure given as 500 mm of Hg. Okay, they can give pressure in different units, so Kp units will also change, right? Whatever terms they give, they will give Kp in same units. Fine. So if they are giving in mm of Hg, you can find in mm of Hg also Kp. They give 500 mm of Hg, and at time of equilibrium, I am saying here, this is 350 mm of Hg. So first of all, using this stoichiometry, find their partial pressure and then find what? Kc. Sorry, find Kp. Okay. After Kp question, we will relate Kc and Kp, and we will see this year NEET question also and the last year NEET question also. Okay. How easy question they are asking. Last year NEET question was a little good, but this year NEET question was very simple from this topic. Yes, tell me. So you see how much it is decreased, how much it is finished. Tell me, bache, you see here, out of 500, 350 is remaining. So how much is finished here, beta? 150 is remaining, right? Out of 500, 350 is remaining. So how much is gone? 150. Now I know its 1 will finish its 1 will make its 1, na? Its 1 will make its 1. So its 150, but I will make it 1. How much? 150. Its 1 make its 1. So 150 make how much? 150. So at time of equilibrium, it is 350. It is 150. It is what? 150. Clear? So what's coming the Kp beta? Kp is very clear. Pressure of what? Pressure of PCl 3. How much it is? 150. How much does Cl2? It's 150 divided by how much? PCl 5 beta. How much it is? 350. Clear? So if you solve this thing, right? How much coming here? We cancel this thing. So I can say 5, 3 and 5 how much? 7. So if you solve this, how much coming? 4, 50 divided by 7. Great, that's it, good. Very good. Okay, so this way, as you have done the question of Kc, same way. Okay, one different type of question comes, I'm telling you. Look at this question very carefully. I'm giving simple data, nothing tough. Same I'm giving. PCl 5. Stoichiometry I'm keeping simple. Equations I'm keeping simple. So that you can learn the concept first of all. Okay. Things remain same even if it comes a little complicated. Time 0 I'm giving. Time 0. And I'm saying here it is time 0. And it is 200 mm of Hg. Initial pressure is given that initially only PCl 5 is present and the initial pressure is 200 mm of Hg. Now what is the question given? In the question is given that if, see beta, if total pressure at time of equilibrium, or I can say total pressure at equilibrium is found to be, if total pressure at equilibrium is found to be, I'm saying, imagine 300 mm of Hg, find Kp. Find Kp. This is the question, right? They gave initial pressure and they're saying at the time of equilibrium, the total pressure is how much beta? Is 300 mm of Hg. Total pressure means pressure of PCl5 remaining, pressure of PCl3 as well as what? Pressure of Cl2. Total pressure become how much? Total pressure is become 300. Fine. Be careful. They can write total pressure or they can write equilibrium pressure is, total equilibrium pressure is how much? 300. This way they can write, right? Now we don't know how much will finish out of our initial pressure given. So look at this question. It's important. Now we don't know how much we'll finish from here. Imagine we are finishing out of 200. Imagine P is gone. We don't know it is how much. Out of 200, P is gone, right? So how much will remain here? I will take 200 minus P, right? Out of 200, P is gone. So how much remaining? 200 minus P. It's 1 makes it's 1. So the P makes how much? P. 1 makes 1. So P makes how much? P. The total pressure at time of equilibrium, if you see beta, total pressure at time of equilibrium how much? 200 minus P plus P plus P. This data they have given. They are telling us that 200 minus P plus P plus P. This is equals to how much? This is equals to 300. Right? So from here I can say, what is the P coming? If you see beta, P coming how much? P coming how much? 100. Now if P is beta 100, if P is 100, then this data how much? This is how much? This is 100, because 200 minus 100. This is how much? 100. This is also how much? 100. Very good. So I can find Kp. The PCl5 100, the Cl2 100 divided by 100. So yes, what is coming final answer? 100. Yes, for Gayatri, right answer. Okay. So this way we can solve the question. We will take some more questions of Kp based on alpha, and then we will see some Kp Kc relationship question also in the tomorrow class. Okay, bacha, bye then. See you tomorrow. Bye.